When and if, and I hope it's if, I hope it's not when, you guys are quarantined. Cannon can vouch for it is difficult. It is, I know it is. You have to watch the video like you're sitting in class. Do you sit in class and just watch me teach? Do you?
No.
If you do, you're not going to learn very much. You have to participate. You have to take notes. And I said at the beginning, you learn by seeing, so I write it. You learn by hearing, so I say it. And you learn by writing it down, so you take notes. Now, when you're quarantined, if you just watch it, chances are you're not going to get it as good. Does that make sense? So when you're quarantined, when you watch the video, you should still take notes. You should still try to answer the questions that I ask and not just veg through it. Does that make sense to you guys?
Yes.
And I don't know, I'm not picking on Cannon. I don't know what Cannon did. But I know that I've got some that said, I watched your video and it didn't make sense. Well, you got to work with the video. Have any of you read my little button up here? I don't think I can read it. Reach it. Have you read it?
No. I didn't see
Yeah, I didn't know that was there.
Now you do. What does it say? It says math is not a spectator sport. You know what that means?
That is not a sport that people play.
No. It means you can't just watch. You have to participate. You have to do it. Any of you all that participate in sports, I'll pick on Cannon again. I picked on him a couple of times. He didn't learn how to play football by watching TV. He had to get out and practice. He had to get out and run and hit dummies and all that kind of stuff. That's how math is. It's a skill. So if you're quarantined, participate. And email me. Email me questions. If you have a question, I'll still answer it. That's what I was taking care of Taylor. It might take a minute. You all were okay with that I answered Taylor, weren't you? So, if it was you, I'd do the same thing. Right? Now, today, back to thinking. We're going to be thinking all the way through next week. By the way, it's not going away. The difference is today is you're going to be given a problem with an equal sign in it. You can work with one side and one side only. And you have to change it until you get the other side. In other words, you know the answer. So I'm not grading the answer, I'm grading the work. All right? Let me give you an example. All right? What page are those on? 568, aren't they? Uh-huh. I will tell you, sometimes you're going to make mistakes. You're going to do some things that you're going to like, oh, that's not working. Erase and go back and start over. That's what happens when you're learning to think. You don't think the right way every time. So don't get frustrated and make sure you have a good eraser. Okay. I can make a choice. I can choose to work with the left side of the equal or the right side of the equal. That's your choice. We're going to use the same rules we used yesterday. Still using the same identities. By the way, we will not learn any more identities until after fall break. So you better learn these between now and then. Yes?
Will there be a way to determine which side would be easier to work with? Or just personal preference?
It's usually personal preference. I'll kind of give you some hints. Like usually I choose the side with more things on it. Okay, but from experience, because you know when you've worked for a million years like me, you realize that it's much easier to go from addition to multiplication than from multiplication to addition.
Okay.
So therefore, I would choose the left side.
Would the sign with more sine and cosine also make it easier?
Sometimes, but this one's even. But it's easier to go from a plus to a multiplication. It just is. So, for this, I can see an identity right off to take care of. Can you?
Negative sine.
This is negative sine of x plus cosecant of x. Now, notice, in identities, I'm working with the left side, so I wrote what I'm doing underneath it. We go down with steps. We do not go across. Because I have to follow where you're going. And I have to know which side you're working with. So we go straight down. All right? Now, what did we say? There's nothing to factor. Could I change everything to sine and cosine? Is that all right with you? So I have negative sine of x plus 1 over sine of x. Would you agree with that?
Yes.
Now notice, I'm not touching that right side. I'm leaving it right where it is. Oh, we don't have cotangent either. Do I have two fractions? Yes, I do.
I was going to ask, so when we're writing this out for like our showing our work, can we leave whichever one we're not messing with alone at the very end?
Uh-huh.
I didn't know if you wanted it written down.
No, you can leave it alone. Do I have two fractions?
Yes.
What do I do? How do I add fractions?
She said, how do you add?
How do I add them?
I'm.
You're all right. How do you add them? Common denominator. What is my common denominator? Sine x. So what does this become?
Negative sine x squared.
Squared x plus 1 over sine x. Is that written correct? Everybody's okay with that? What is negative sine squared x plus 1?
Negative cosine of x.
I think it's positive cosine squared x.
Yeah, it does.
Isn't it? You all agree?
Yes.
So do I have cosine squared x over sine of x? Oh, some of you are seeing it.
Yeah.
Look.
Lost it.
What? I just changed to use this identity. Negative sine squared plus 1. Isn't that an identity? You're supposed to be on the page with the identities in front of you, Andy. Turn to page 568. You're not seeing what?
It's
It's the first
So,
Pythagorean identity.
You just got to move it around.
Yes.
It's moving parts.
They're all the same part.
So you could do sine the other
You're
side.
exactly right. They're all the same parts, but you can move
Pythagorean
them around.
identities are very
Okay, look how close I am.
Yeah.
Do you see it? Is this cosine of x over sine of x times cosine of x? Whoops, sorry, went the wrong way.
Yeah.
Is that what this is?
Yeah.
Wait, wouldn't
Oh,
cosine
we
of
got
x over
we got
sine
it.
of, like,
Is it? Is this the same thing as this?
Yeah.
I just, instead of writing cosine squared, I wrote cosine times cosine, didn't I?
Mhm.
What is cosine over sine?
And,
Cotangent of x. What is this? Cosine of x equals cotangent of x cosine of x. My very last step, I state that they are exactly now the same.
Yep.
Did you follow that one?
Yes.
That wasn't awful, was it?
not too
This takes up a lot of space.
Takes up a lot of space.
complicated.
Space we have. What happened?
They don't call me the old.
They don't call you Woodsy Woodsy.
They don't call me the old.
They don't call you Woodsy.
Let's do another one.
It's not discriminating. Here. I think some of us have had it beginning. You're gonna regret that. No, come on.
1 over 1 plus secant minus 1 over 1 minus secant equals 2 cotangent cosecant.
I see an identity.
Huh?
Yes. So
Yes.
I don't know what he's saying.
I said I see an identity, right? So
It's not an identity, is it?
well, it's not an identity, but it's you could make it an identity.
Well, I hope that's our goal.
Yeah. So
That is our goal.
so if tangent squared plus 1 is equal to secant squared of x. Is that? I mean, no, can't use that.
I don't know what you're telling me. I know tangent squared is equal to, but I don't have a tangent squared.
That's true.
Lonzo's like, hey, reality can be
My
whatever I
question
want.
was left or right? Left? Left.
Lonzo goes, reality can be whatever.
You were thinking out loud? Okay.
Yeah.
I'm working the left.
Just play 40.
So,
On the left, do I have two fractions?
Yes.
So what am I going to do? How do I add two fractions? Common denominator. What? I thought you had a question. Isn't the easy way to multiply the two together?
so earlier we said that it's easier to go from addition to multiplication, so that goes with subtraction as well?
Yes.
It's easier to, okay,
Yes. Because subtraction is just addition with a minus sign.
okay. I just wanted to,
All right, here we go. Isn't my denominator 1 plus secant x times 1 minus secant x?
Is there a reason we don't just write it as a square to decrease the squares?
My reason, Liz, was because I was afraid it would confuse somebody if I skipped that step. So, as far as you're concerned, absolutely not. There's no reason. Other than I didn't want to lose somebody. Okay?
Yes, thank you.
So, what is this numerator?
1.
This numerator?
1.
One.
1 minus secant x. Right? What is this one? But isn't it minus the whole thing? All right. What's my new numerator? New. Did you catch that? I think it's that. That works?
How'd you get -2?
Well, negative secant minus secant is negative 2 secant. Right?
Wait,
Hold on, wouldn't that
Yeah,
be
how is it?
secant squared?
No, secant plus secant is not secant squared.
It's because it's minus positive.
Doesn't this minus have to go through that parenthesis?
You subtract -6.
So I have 1 minus 1. That's gone.
Zero. And then it's negative secant.
Yeah,
Negative secant minus secant is negative 2 secant.
Oh, okay. I was thinking it was the ones that in the.
Yeah, no, I had it right.
I didn't realize
Yeah.
it was canceled.
Sometimes you do. So what's on the bottom? If I were to FOIL. Right?
Yes. Yeah.
I have to get rid of my denominator. So I need it to go to one thing instead of like, now it's 2 parts, 1 minus secant squared.
Yep.
So what is 1 minus secant squared? Is it anything? Are you sure it's 10 squared? Are you sure? I think it's negative 10 squared.
10 squared, yeah.
You changed your answer? So I have negative 2 secant x over negative 10 squared x. Right?
I was just thinking that.
You were way ahead.
One's will be like 5.
What do my negatives do?
Cancel.
Cancel.
So it's still.
Okay. I have the 2 I need, don't I?
Oh, I see.
Do I have 2 secant x over 10x tan x?
Yeah.
Right? Didn't I want one of my parts to be cotangent? So I've got, I have 2 and I have cotangent, don't I? Here. So I only have this part left to work with. Right? Tell me what secant is. So I have 2, we said cotangent x. Is it 1 over cosine over what is tangent?
Sine over cosine.
Do you know what that reduces to?
Cosecant?
1 over sine? Which is what? Cosecant? So I have 2 cotangent x cosecant x equals 2 cotangent x cosecant x. Right? I will tell you, if you do not write that last step, I will count it wrong. Just don't get lazy.
Wait, so the original problem on the other side was cosecant, not secant. I think I just wrote the thing wrong in the first place.
I hope it was.
Yeah, I just wrote it wrong.
And that makes it really hard to work when you have part of the problem.
Especially to get the part that you have equals to wrong.
I somehow got the wrong problem, but right. I feel like
You got the part
I
wrong.
would have put in all that work just to do
Yes.
nothing.
So on the last step, what did 2 cotangent x come from?
Didn't,
2 cosine.
1 over tangent is.
where did
Oh,
what
no,
come
it's
from?
okay.
Did you need to see it?
I thought it was that cosine. I thought you had written cosine.
Oh.
No.
One more? I'm going to tell you, you're either going to like them or hate them.
That's like solving a puzzle.
Yes, it is.
You get the satisfaction.
Yeah. You either like them or hate them. Andy, don't do that, please. Yes.
Before we get too much into this next one, will there ever be a time to where on either side they're both addition or both multiplication? Either side.
Yeah, this one.
That's a lot.
Well, it's got to equal something. Goodness. That's a third.
Alright. Hold up. Division. No.
I want to work the right.
Yeah. Here's a little bit front.
You agree?
Yes.
So, care you? I work the right? Okay. On the right. Excuse me. Is it true that I want my denominator to go to 1?
Yes.
My numerator to go to 1, thank you. Isn't it?
Yes.
So, I need to get the right side where I can factor something. All right? So, I want to know, can I do this? Is it the same thing?
On the go scale. Yeah, we can do that too.
I didn't use an identity, I just said cosine cubed is cosine times cosine squared.
Oh.
That's all I said, right? And that's a true fact. And the reason I did that is because cosine squared, I can switch to a sine. And that's the only way I'm going to get rid of my numerator is if I can get the bottom in terms of sine. Right?
Yes.
So, what is cosine squared?
Cosine squared is 1 minus
Is what?
1 minus sine squared x.
1 minus sine squared x. Right? Will 1 minus sine squared factor? Yes? How does it factor? One plus sine x, 1 minus sine x.
How did you get the external sine?
I have a question.
Oh, that's a cosine, isn't it? Sorry. So I told you to have a good eraser.
That 1 minus sine x. 1 minus sine x.
Oh, Lorenzo says we can cancel something. You agree?
Wow.
So now what do I have on top? 1. And that's what I wanted, didn't I? A 1. And we can distribute the bottom, which gives me cosine x plus sine x cosine x. Is that what I wanted?
I think it's because
It was fewer steps, but you had to see at the beginning to split up the cosine cubed. So the beginning probably was a little bit more difficult.
but then once you get rid of
But once you did that, it was like, oh, wow, this is okay, I can do this. Right? Does this make sense? A little bit.